Solar cooker. The box type solar cooker has a insulated box painted black inside. Now why black? Because black is a good conductor of heat. The same principle which we just discussed about the global warming, the trapping of heat inside the atmosphere, something similar to that is used in solar cooker. Suppose I have a black color box here and it is covered with a glass lid. What will happen now? Whatever sun heat is coming inside is getting trapped inside, so it is increasing the temperature gradually. So at some point it is going to reach optimum heat or optimum temperature which is required to cook a food substance. So that is a solar cooker. So it is covered by a glass plate which allows heat to enter inside but does not allow it to escape out. It has a mirror to reflect more sunlight to it. So it's not just the area of which it is made up of, even extra reflection heat is coming through it. The food which is to be cooked is kept inside a container box, and it can produce temperature of about 100 degrees Celsius to 140 degrees Celsius. So see, a small box just by using sunlight can produce so much of heat. Solar water heater. This is, I'm pretty sure that most of you have already used. These days in winters, instead of using normal geysers, we prefer solar water heaters, because in solar water heaters it is absolutely free of cost. Just one time installation cost is there, and then we can get good water, good warm water in the winters. So solar water heater has an insulated box painted black again inside with the system of copper tubes. It is covered with a glass plate which allows heat to enter but does not allow it to escape. And then the water flows through the copper tube which is already hot because it is placed inside that box, and when the cold water passes through the copper tubes, copper is a good conductor of heat, water gets warm, and then we get warm water in our tubes. Then this and this is a water heater and this is a solar cooker. See, the box which is placed with these things, suppose whatever I have to cook, I am placing it inside and I am closing the lid which is made up of glass. So sunlight which is going in is not coming out, plus this black coating is helping temperature to rise very high. Second part, the mirror, it is reflecting more heat into it. Now there is a very huge disadvantage with it. Not that sunlight is not available all the time. If you have a cloudy weather, then obviously you will be getting on and off sunlight, so it is going to be an issue. But I'm not talking about that. If any one of you has ever used the solar cooker, you will see that it becomes really hot and we just can't touch it. So now if you can see, there are small wheels below it to move the whole solar cooker, right? So there are insulated handles provided, but it's sometimes it's a bit hot to use. Now this is solar cooker and this is solar water heater. These are what? These are the copper tubes, and it is the copper tube is inside the glass material where the heat gets trapped and it heats the tube, and that tube carries the cold water, gets converted into warm. Solar cell is nowadays very much used. Solar panel, solar cell. So solar cell is the best way to use electricity or to convert the solar power into electric power. How? See, in this class I will not go into too much of technical details how solar cell creates current, but I'll tell you a very simple thing. Current means flow of electrons, or I'll talk it in more layman language. Current means flow of charge. Okay, so solar cell, what it does, when light or sunlight falls on it, it creates charge which is free to flow. So basically sunlight, without sunlight it won't happen. So sunlight is creating that free charge which can flow in a wire. So that is why we are talking about solar cell. So this whole device is connected with wires to a bulb and it will glow. Now these are solar panels, because just one solar cell is not sufficient enough to give the electricity to the entire house. So then for that we have solar panels. So one solar panel has n number of, sometimes 100, sometimes 1000 number of solar cells. Solar lamp is the same street lamp which we see every day while walking, but the street lamp does have an extra benefit that it is added on with the feature of solar panel. So a small solar panel can lit this light for up to 8 hours. Then next, now we are going to talk about energy from the sea. We have discussed that energy from sea can be harnessed in few ways. For example, we have ocean thermal energy, we have wave energy, we have sea wave energy, ocean, and yeah, tidal energy. So tides, let's talk about tides first. What are tides? See, fluids can easily flow, right? Fluids, because why they can flow? Because they are liquids, they don't have their shape and size of their own, and fluids can get attracted to attractive forces. So earth, which is under constant gravitational pull of both sun and the moon, so sometimes the water is pulled away from the shore, whereas sometimes water is pulled towards the shore. So when the water, the whole ocean water is pulled away from the shore, we say that it's a low tide, and when it is pulled towards the shore, we say it's a high tide. That's what we call tides. So the periodic rise and fall of sea level due to gravitational attraction of the moon causes tides. A dam is constructed at the place where tide is happening, and then we accumulate the tidal and water, and then we'll release it via turbine. So this is how we do it. Sea wave energy, when strong wind blows over the sea, it produces huge waves. Now that wave can be made to fall under streamlined concrete bunkers, so that it will create air pressure, and that air pressure is going to force turbine to rotate, and then that turbine is going to give us electricity. Lastly, ocean thermal energy. You know the temperature in ocean is high because the water is in contact with the core temperature of earth. Even the centermost part is, though we haven't even reached the centermost part, we haven't even penetrated more than 3 kilometers till now, but even if you go a kilometer at depth of the earth's surface, the temperature is going to be really high. So water or oceans which are at huge depths, the temperature at the bottom is a bit large. So we just use the fact that there is a temperature difference on the floor of the ocean, on the top of the ocean. So there is a temperature difference between the warm surface water and the cold surface water at the bottom of the oceans. This difference is about of 20 degrees. So the warm surface water is used to boil liquid ammonia, and then liquid ammonia gets converted into gaseous state or the pressurized steam, which can rotate the turbine, and then the expelled steam can go back to the core temperature zone, and it will go again into the liquid state. So the main key player here is ammonia, okay, liquid ammonia, not just ammonia. The warm water surface is used to boil liquid ammonia, and the vapor is used to rotate the turbine of generators to produce electricity. The cold water from the bottom is then pumped up to cool the vapor back to liquid. Now, this is what tidal energy diagram would look like. This is the gate, which if lowered, the whole high tide can flow into this region, and the main gate is closed. And then this main valve is closed, which is opened as per convenience. So the water is made to fall back from the turbine, and this turbine gives us electricity. This is how sea wave energy is covered. This sea wave, this concrete structure is made in such a way that whenever wave hit this part, this creates a huge air pressure, and this air pressure rotates the turbine. This is called oceanic wave converter or OWSU type generator. These windmills, this turbine turns in same direction irrespective of flow of wind. So that is the best part. So see, here two things are happening. Not just that water is being pushed here. When water will fall back, it is also going to pull back the pressurized gas, which is what, trapped here, or air. So when it is pulled back, it again rotates the turbine. So it is done in two steps, not just one. This is a schematic of OTEC floating platform, oceanic thermal energy converter, and here we have already discussed that liquid ammonia. This diagram might be a little blurry to you guys, but I'll explain. This is efflux, where liquid ammonia is channeled through and back. So liquid ammonia is getting converted into steam. The steam is rotating the turbine, and we are getting the liquid ammonia back. Now, we are talking about geothermal energy.